It was a great pleasure that I could introduce my old friend Harold Williams. Harold is the director of the Planetarium at Montgomery College since 1990. He's also the coordinator of the physics laboratories in the astronomy program. He was originally from Jacksonville, Florida. Got his Bachelor of Science with a double major in physics and math from Florida State, his master's from State University of New York in Sunnybrook in relativity, and his doctorate from Louisiana State University, where he studied star formation using a 3D explicit Eulerian hydrodynamics. I think I'll stop there, and Harold will tell us about astrolabes.
Okay, well, I got interested in astrolabes when I went to LSU, and I was assigned to teach an astronomy class, and I got a hold of a book that talked about how to build one. So I made one, because if you really want to understand how to use an instrument, you got to make one. Now, I have some astrolabes around here, and I also have some things that are not astrolabes. This is not an astrolabe. It's called Constellation Board. It doesn't preserve angles, it does preserve shapes. This is also not an astrolabe. It does about the same thing the other thing does, right? And this is also not an astrolabe. A precession, equinox, historical, plane sphere, but all these things are plane spheres. Now this thing is called an astrolabe, but it probably ought to be called an Astrolabe Quadrant. And the good ones, of course, are made out of brass, and they were measuring. Plane spheric astrolabes have one of these on the back to measure the altitude of stars, so you can, tell the time, tell where you are, and do all kinds of interesting, curious things. So, all or most of the astrolabes. And I'm no longer the director of the Planetarium. I'm the director of the Universarium. That's not a real word, but I made it up, but it's going to become a real word as soon as the Oxford English Dictionary recognizes it. Because in a new video planetarium system, you can put up the Sistine Chapel. You can put up fish biting your ankles like Rupert just filmed, in Virginia. I mean, it's almost like a holodeck. Not quite, but things can't touch you yet. Anyway, so I teach and do these crazy things at Montgomery College, at the Tacoma Park Silver Spring campus, and let me see. I'm going to face this way. Rupert wants my face for some reason. Okay, and that's in Montgomery County, Maryland, the United States of America, on the planet Earth, around Helios, Sol, Sun, Star, in the Milky Way galaxy, an outlying member of the Virgo supercluster in Laniakea.
It's a supercluster.
That's a supercluster, but includes the Virgo supercluster.
Which arm of the galaxy and which continent?
Well, I didn't put those down, but you know that anyway, Rupert. Rudy. So anyway, next slide. Well, now this is a plane, whoops, come on, whoops, I pressed the wrong button. Let me get this out of the way so I won't keep pushing the wrong button. Or maybe push the right button. And the right button is the right button. This is a plane spheric astrolabe. And this is what people mainly mean when they say an astrolabe. And an astrolabe has to have at least two parts. It has to have a rete, which is, the celestial sphere flattened, and it has to have a climate or a tympanion. And on the rete, it has to have an ecliptic circle, because if you can tell time, you need to know where the sun is, because we tell time by where the sun is. So the astrolabe tells time according to where the sun is. Now, when the sun isn't up, you have stars that are up, and those stars are in relation to the sun somewhere. So even when you can't see the sun, you read the time off of where the sun is, even when it's not above the horizon. So all good astrolabes need a marked ecliptic. And in fact, my friend here, Rupert, bought something that looks kind of like an astrolabe, but it doesn't have a marked ecliptic. So you can't tell time with it. So it's effectively useless. Now, you could engrave it and maybe make it useful, but at its current state, it's not quite useful. In fact, I didn't take that out of the thing. So I'm going to get down here and take that out, because I think it's kind of interesting to know that not everything that looks like an astrolabe really is. So this thing kind of looks like an astrolabe. Can you get it, Rupert? And,
No, I got a problem here.
okay. This is kind of, and it looks like an astrolabe. It has a cotter pin. It has a climate, but
Is laid from labor?
yes, labor or finder, taker, thief.
Okay, it's working.
Okay, so this is not a real astrolabe. You could probably engrave it and modify it and make it a real astrolabe, but right now, it's not a real astrolabe. Okay, because it doesn't have this ecliptic circle marked off.
Put another camera, Harold.
What?
There's another camera.
Oh, right, okay. So, and here's the back of it, and it's interesting.
Harold,
What?
I have a question. The REIT points to this thing that circles around there, and the ecliptic circle points to the same thing. What?
The ecliptic circle is on the reed,
ecliptic
because the
circle
sun is
on
a
the-
star.
the REIT
And I'll
is
be
the
getting to
larger
that
one.
in a moment, because I got lots of pictures, and this is only the second one.
Right, okay.
Now, here's a game called Magic, the Gathering. And on this card is an astrolabe. So, or something that claims to be an astrolabe. So, I mean, it's made it into common culture too. Now, here are the parts of an astrolabe. To be a plain spheric astrolabe, it has to have a reed, and you can see that particular reed does have, let me get out my laser.
You got an extra pointer?
Yeah, I got one. I got 2 or 3 of them, in fact, so I got lasers up the bazoo. So, you can see, this is the ecliptic circle. So the sun is along here, and this would have to be marked off. Now, there's a star here, a star here. These are star pointers. And this is kind of the European design, because the little pointers aren't curved and not particularly artistic. I'm wearing an astrolabe, and this is the kind of astrolabe that Chaucer would have used. I wear this when I wear the black robes when I graduate people. So when I look like a penguin, but I'm a penguin with an astrolabe around my neck, and students can find me that way. And you can see this has the ecliptic. So it has to have a reed, and this is stereographic projection. Then it has at least one climate, but it can have more than one climate, because astronomers and scientists, we tend to be vagabonds, and we move around, so we change latitudes, and we change places on the earth where we are, so we go different places. This is called a climate or tympanic, but this is latitude specific. So if this is made for here, then these other plates would be made for someplace else. The whole thing's got to be held in a matter, and the backside of the matter may be engraved too, and maybe a climate. Then on the back, there are all kinds of different things on the black. Most of them have sights on the back to measure angles, but sometimes they also have an arm on the front too. And everybody who has ever made an astrolabe has made an astrolabe a little bit different than anybody else. Now here's the Montgomery College Planetarium astrolabe. This is the modern version. It's the modern version because the ecliptic is not marked off in the signs of the zodiac. The ecliptic is marked off in dates. So you can find where to put this thing on the date, because the date's marked off on the ecliptic, which is pretty convenient. And the spider's web, anything that is in the spider's web is up. The center of the spider's web, right there, is directly overhead. The pivot is, well, if this astrolabe is made for the northern hemisphere, then that's where the North Pole is, right? You can make them for the South Pole and a plain spheric astrolabe. And there are other astrolabes that use all kinds of other crazy-ass projections, but I don't think I brought any of those with me.
Are those dates accurate for 25,000 years?
No, I'm coming to that, because the thing is, first of all, we have precession, right?
Yes.
And I'm going to show you a series of these plates and show you how they change through time. Also, over longer periods of time, this stuff changes too, right? So all this can be used to date an astrolabe, or at least where the astronomical catalog was that was used when the astrolabe was made. And sometimes those are not quite the same thing. But anyway, so those are the parts. Now, here's another parts of an astrolabe. The rete, or the net in Latin, star map, off-axis circle is the ecliptic, and the signs of the zodiac along here. So you can also use this to catch horoscopes. It's a pretty useful thing. Back in antiquity, you could make a living that way. And these are plates, and this one has multiple plates, and it has the thing in the back here, the Astrolabe, is for taking sightings. This one, Rupert's fake astrolabe here does have one, and it does have a distance scale. So this is how you measure the angle of stars at nighttime. And most of these astrolabes have something to take sights on the back. Although we'll see that they have all kinds of different things on the back, depending on who made it and when and how come. Okay. The rete uses stereographic projection. The ones designed for the northern hemisphere project from the south pole. So I have a star on the celestial sphere, and I project it through the plane, right? And that projects the star right there. And I can also do the same thing for the celestial equator, the Tropic of Capricorn, the Tropic of Cancer, and for that matter also for the ecliptic, right? Using stereographic projection on your plane spheric astrolabe. Okay, so here's a Janus astrolabe rete, a modern one, and you can see this one has the signs of the zodiac right on it, and we're now going to see how that's the North Pole. This is Cassiopeia. This is the summer-fall triangle with Vega, Deneb, and Altair. This is the Great Square of Pegasus. And this would be the first, when the sun is here, it's the first day of spring. All right? So all the seasons are here. And you'll have anywhere from 20 to maybe 100 stars on your typical astrolabe. Although I'll show you the electric astrolabe, it has the planets. Now, most astrolabes that are made out of metal or cardboard don't have the planets. But all the planets are going to be moving near the ecliptic, right? Conservation of angular momentum. So, the Earth goes around the sun on the ecliptic, our way of looking at it, or the sun goes around the Earth on the ecliptic, depending on whether you're heliocentric or geocentric. But all the planets. But they're not on most of your astrolabes like this. Only on an electronic version knows all the motions of all the planets. Everything else. So that's okay. So here's one for 2,800 BCE. And a lot of things are different, right? I mean, notice the position that Orion has moved, right? Because there's been a lot of time. And precession equinox and all that kind of stuff, right? And here's one for 500 BCE. And here's one for 140 AD, right? That's time of Claudius Ptolemy. Here's one for only 19 years ago. This will work pretty good. In fact, see, you can use the rete to tell approximately what date you're dealing with to start off with. So here's a rete for 13,400 AD, when Vega will be a pretty decent North Star, which it is not now. It does get overhead here, near overhead here every day, but not now. But just wait a few thousand years, and about 10,000, 11,000 years, and it will. Okay, so now I've shown you how to make the rete, but I haven't showed you how to produce a climate or a tympanium. So this takes all those horizons and makes so that's the overhead point. That's the overhead point. The observer's zenith right up there. That's the North Pole. So you can also tell this thing has to be drawn so that this is on the 50-degree circle. So this would be this would be a tympanium for 50 degrees north. That'd be north of New York City even. All right? And you also do the same thing for the equator, the Tropic of Cancer, and in most plane spheric astrolabes, they do not go further south than the Tropic of Capricorn. But I will show you an astrolabe made by me. Well, I go all the way to the horizon because there was a fairly bright star in Baton Rouge, Fomalhaut, that was lower, and I wanted to show it. And so it creates a lot of distortions on the edge because while the thing is angle preserving, it is not shape preserving. So here are the almucantors. So these are directions. So this is north, this is south, this is, okay, this is, one of these is east and one of these is west. All right? Now on some of these astrolabes, they'll have it written east and west over here, but it's really this curved line that's
Well, I see
east and
30
west.
I see 30 degrees right there, and
Yeah.
they do have numbers around the edge.
Yeah, these are azimuths, right? And actually, most of the time you'd call this 0 or 360, and you'd call this 180, and you'd call this
90.
270, and this would be 90. But there's 90 degrees from here to here, and 90 degrees from here to here, and 90 degrees from here to there, and 90 degrees from here to here. And
Yeah.
4 times 90 still gives us 360, because this is, you know, ancient Babylonian 360 degrees in a circle kind of stuff. No 2 pi radians. Okay. Physicists had not yet been invented when this was invented. So here are hour angles, unequal hours. Because there are different ways of dividing the night so that you have 12 hours of nighttime and 12 hours of daytime. But in most places around Earth, an hour of day and an hour of night, this thing are not going to be equal. But it depends upon how you're dividing the division when you're keeping time. So, you know, your watchmen don't fall asleep in the middle of the night. The enemy come and butcher you, something like that. The astrolabes have to be able to tell time. They can also make predictions, like what time sunrise is going to be, what time sunset is going to be, and all kinds of other things that you can do with an astrolabe. So here it shows the ecliptic and its projection. And you can see the summer solstice, the winter solstice, the vernal equinox, and the autumnal equinox are going to be special places along the ecliptic. And this is also going to be divided off, either in the signs of the zodiac or the dates, depending upon how you've made your astrolabe and how you've done it. Okay? Now, so here is, again, a close-up of that sort of thing, showing where the winter solstice is on this particular climate when it's rotated this way. All right? And here's a completed climate or tympanium, which shows the zenith, which shows the different altitudes. This is the horizon. And these are lines of equal azimuth. They're called almucantors. And these are hour angle lines, so you could tell time at night with your device. But everything that is going to be inside the spider's web. Now notice this type of astrolabe does not show all the horizon. It shows the horizon in the north, but it doesn't show all the horizon in the south. Although some fool me made an astrolabe that does that. Of course, that creates a lot of distortion in a few places. So here again are hour angle projections. So this shows the hour angle projections. And they're 12 hours and half a day, and so that's why there are 12 of these, sometimes called Babylonian hours, depending on the writer and who's doing what.
But they don't account for daylight savings time.
No daylight. You can do that if you want to. Now I'm going to show you how the climate changes with latitude. So if you live at 25, there's there. And for one thing, you can see the North Pole is at 25. These are actually, okay, these are all sunrises, these are all sunsets. When it's on the horizon, we talk about sunrise or sunset. When it's 6 degrees below the horizon, we call civil twilight. When it's 12 degrees below the horizon, we call that nautical twilight. And you can't read the binnacle on a ship without a light at that point. When it's 18 degrees above the horizon, it's really, really dark, and you can start doing photometry with a telescope or device without making any corrections for the fact that the Earth has an atmosphere and you're getting shine from that refraction. So this is for 25 degrees. So this is for 30 degrees. This is for 35 degrees. You see the change that occurs. The main change that occurring is this thing is getting bigger. You're also seeing that the hole with a pivot point is in a different place. It's always the angle that the climate is made for, right? Because, it's the way it all works.
The latitude?
The latitude. So this is 40 degrees latitude. So this is near us. This is not quite as near us, all right? And continue on. So we go further north. So here's 45. Here's 50. Oh, this is typical, too. It says this is west. Really, this is west. Really, this is east. This is really north. This is really south. Well, that's right. This depends on how you want to label these things. So that's 55. That's 60. You're getting pretty far north now. Now, this is a coordinate transformation plate for both 0 degrees and 90 degrees. So 0 degrees is the equator, 90 degrees is the pole. So this is for the North Pole. And that's a coordinate transformation device. Here's another one. This is plane for ecliptic transformations. Because the ecliptic is roughly 23.5 degrees, or 23 and 26 minutes if you want to be smart aleck. And the Arctic Circle's latitude, and so on and so forth. Now this is for our friends that want to do horoscopes. Because when you do a proper horoscope, besides knowing the person's birthday and knowing their sun sign, you also have to ask them, find out from their mama when they were born, what time. Because besides the fact that the sun is in a particular constellation when they were born, they were probably not born, may not have even been born when the sun was up. So there's a constellation on the ecliptic coming up. That's called the ascendant. There's the one midheaven, and there's one descending. So that gives you 4 constellations to play around with when you cast your horoscope. You've got a sun sign, an ascendant, a midheaven, and a descendant type. Now, if you're not very imaginative, you read the book and tell your client what comes out of the book. If you're more imaginative, you make up something more creative. What you do is you tell the person, here's how it's really done. Most people have pretty good opinions of themselves, so mainly you say that their astrolabe their horoscope is predicting good things about them. But you find at least one flaw in their character, because everybody knows they're not perfect, except for maybe Mr. Trump. But anyway, even he knows he's not perfect. But anyway, he just won't admit it very often. But we all know that we have imperfections. I have lots of them. Okay? For one thing, I spit when I talk, so don't get too close to me because I might spit on you by accident. But this gives you ascendant and descendant lines in 5-degree increments. So somebody casting a horoscope, by the way, there is one of those plates in that Persian instrument right there. So, which, by the way, moved to a village outside of Mumbai. So in the naming of children in India, horoscopes are really important. And they tend to want to use the horoscope that is appropriate, although that's 500 years old, so that would have been really good for 500-year-old children, but not so good today. That belongs to Montgomery College, too, and it was made in Persian. And it has 2 languages on it. It has Arabic and Farsi, so you have to have 2 translators. And your Arabic translator can't be your ordinary Arabic person because it's written in a very strange Arabic script, sort of like Frankfurter is in German, So, but fortunately, at Montgomery College, we have 2 employees whose mama is from Morocco, and she's an expert in all kinds of things Arabic, including she's translated the Arabic on that particular device. But she doesn't know Farsi. That thing has Farsi on it, which isn't surprising since after all it was made in Persia. So yes, it has Farsi on it as well. So you've got to have another translator to translate the Farsi part of that particular instrument. And of course there are instruments that even have some English on them, or Middle English if it was made by Chaucer. So now,
Chaucer made them himself?
Chaucer wrote a book in 1387 called the Treatise of the Astrolabe. So Chaucer wrote the first work in science education in 1387, directed for little Louis, who was a 10-year-old son, about the astrolabe. Because little Louis had already picked up on the fact if you knew how to use one of these, plus Chaucer evidently gave him one like this. This is like a Chaucerian astrolabe, except for the climate here is made for the climate of Berkeley. And Chaucerian astrolabe would not have a Phillips head screw on it because Phillips hadn't invented screws yet. It would have been a horse-shaped cotter pin. So you could slide that thing out, and the more expensive ones, which I don't have multiple plates. This I bought for about $100 from Barnes & Noble's Arts and Artifact catalog. And it also has a back with other stuff. So this is a shadow square. So what's on the back of the astrolabe is highly variable. Many of them do have shadow squares. That allows you to do trigonometry, sines, cosines, and tangents. So you could use that for all kinds of things. Now, I want you to also notice, okay, besides having degrees, so if you had a scale here, you could read, the altitude of things. It also has two circles, but they don't have the same center. Because the Earth's orbit is actually slightly elliptical. And we're closest to the sun in January, we're farthest away around July. And that shows up, or the anomaly of the ecliptic, that shows up on a properly made astrolabe. And you can see that. You can see there's a bigger space in here and a lesser space in here between the circles. So that's important in an astrolabe. And you can also say this also has all the signs of zodiac and the date. So you can, and most astrolabes have marked on it not dates like this on the ecliptic, but signs of the zodiac like this one. So then you have to do it two different ways. You have to find your date, what sign of the zodiac are, so you can set this thing right to get that sort of thing to work.
What's a shadow square?
It's the thing to get sines, cosines, and tangents off of. I've never actually used one, but anyway, in the book that comes with the manual, okay, this is a Janus astrolabe. These yellow things are Janus astrolabe. The Jim Morrison, he's dead now, so he's not making them anymore, but I have a few left over. And this one, notice, has something else on the back. This allows you to get to watch time. In fact, this not only allows you to get to watch time, this shows you how to do the computation to get to watch time. Because once you get local apparent solar time, then you have to add 1 hour, not hour, because of daylight savings time. Then you have to correct for the fact that right now we're about at Tacoma Park, we're 8 minutes away from the center of the time zone. Here it'd be a little bit different. Minus ET. ET is the equation of time. That's this kidney bean thing. And that's caused by two things. It's caused by the fact that the ecliptic is 23.5 degrees away, and the Earth doesn't actually move uniformly around the sun because it has an elliptical orbit. So we're sometimes a little faster, sometimes a little closer, and that can cause an equation of time correction up to about 15 minutes, plus or minus.
So this is.
So if it has the peanut,
A mechanical analog.
right, so yes, catalog element. So if it has the peanut, like the modern version of the astrolabe is, what Jim was selling, this allows you to go from telling the time, which is local apparent solar time, to then to get watch time. So you can set your watch when you're in the middle of the woods or wherever, right? Of course, you can also go the other way, right? You can take your watch, compute what local apparent solar time is, set it up, and see if the sky's behaving correctly, which it always does. So notice the perihelion and aphelion, the center is the calendar of zodiac, do not combine. And there's an angle measuring protractor, and it's got to have a calendar and the signs of zodiac around it, or, it's not much. Unless it's like one of these that actually has the dates on the ecliptic. So this does have the signs of zodiac, but here to be an astrologer, you have to flip it over. He did sell versions of it that didn't have signs of zodiac, so you couldn't cast horoscopes unless you used a different method. Depends on what you want to do with it. So here's another. There's talking about the Twilight Arcs again, right? The Twilight Arcs, that's the horizon. -6 is civil twilight. If it's, you got to have your car lights turned on. -12 is nautical, and -18 is astronomical. And this is just a review of north, east, south, and west, and the degrees around the azimuth circle. And these altitude circles and these azimuth or almucantor circles. Lots of circles on the astrolabe. Okay, now we get to modern physics. The astrolabe projection, I almost fell out of my seat when I got this book, because this is an astrolabe projection. This would be the south, that'd be the north, and that'd be a star on the celestial sphere. But this is for spinners. Yes, fermions, spin-a-half particles, follow the same mathematics. So this is 4 pi or 720 degree symmetry. Oh, a good piece of mathematics. Here's from the book, stereographic projection, some mathematical projection, same mathematical projection with the astrolabe and for spinners. This is from that book, which I own. And here's some equations from that book and some corrections and, relationship between rotations, three-dimensional physical space with spaces, spinners, and so on and so forth. And this is really cool mathematics being used in the 20th century and now the 21st century to describe fermions. And here is Eli Cartan's later book. Eli Cartan actually talked about spinners before Dirac and Pauli did stuff. And you can click on here and you can pull up the whole book and you can own it too. So I own this book because these are all, it was like this, it's an active link, and this will be posted at the website. And so this is the theory of spinners by Eli Cartan, topic spinners, Dirac, Minkowski, Riemann, special. Now when he wrote this, he had a version of the special theory of relativity. The correct version of the special theory of relativity has to, if you couple it to a fermionic matter, has to not use the metric. He has to use something called the tetrads, which is kind of like the square root of the metric. That's what really gets coupled to the metric. And it's possible that it could have, because Christophel's symbols of the second kind, Einstein made symmetric. But he did that because he wanted to write it in terms of the metric. But they don't have to be.
But that's the simplest case.
That's the simplest case, and it works for planets. And it works for most applications of general relativity pretty well. So you can get away with that. And it turns out that if there is torsion, it only doesn't propagate in the vacuum, it only propagates inside the fermionic matter. So it can be factored out algebraically. And all this is Mobius strip stuff. So here's a Mobius strip, just to remind you of the Mobius strip.
That's where the 720 comes in.
Yeah, so anyway, so also in the theory of spinners by Masha Kermeli and Shimoni Malin. And Kermeli had a book on spinners. He has a book, also there's another book there where he doesn't need any dark matter. He doesn't need any dark energy. Now, his relativity has not 4 dimensions but 5. So, obviously you got to add something else to get you there. Who knows what the Creator chose, because we don't have, experiments are not in yet that unambiguously answer the question. Okay, here's also another good book I would recommend, which also mentions some of this stuff.
Another impenetrable book.
Yeah, listen, if it took Penrose 8 years to write this book, it's probably gonna take me 16 to 32 years to read all of it. Now, I've read bits and pieces of it, skipped around, underlined. I actually have owned 3 copies of this book. The first one the cat peed on, so I had to get rid of it. Second one, I bought another one. Then I got an illegal PDF version since Roger had already gotten money from me twice from the book that I bought. Didn't bother my conscience too much when I got the free PDF one, which I have on my iPhone and my iPad. It's a great book. And it really is a road to reality, even does cover strings. Now, people are still making astrolabes, and they're not all made out of paper and cardboard and plastic. This is, I hope this astrolabe is still around. Notice it was made in a town that has been bombed the hell out of in that civil war they had in Syria. If you
Or
look at
still
pictures of
having.
Aleppo, I hope it was an underground vault and didn't get blown the hell up. But, okay, this is not a reproduction of a Pacific instrument, but a style typical of a high-quality Islamic instrument. So here's the reed, here's a rule, here's the cotter pin, it's a horse shape, and here's 1, 2, 3, 4 different climates or tympaniums. This is a really great instrument, I'm sure. Here's another one. Okay, this is in some museum. Okay, and you can see the prettiest ones are generally the Arabic astrolabes, and you can see it as Arabic, or the Farsi ones. Beautiful. Now, most of these astrolabes are this size or this size. You very seldom see one that big, the size of a dinner plate. That you could only hang on the wall. Like I said, if you try to hang it around.
Hard to carry around.
It's hard to carry around. I put it on a backpack and it hurts me. Here is the reed from this instrument right here. And this is how I authenticated this astrolabe was a real astrolabe last century. Because I don't read Arabic and I don't read Farsi. But by the position of these stars, I could tell that it was real. Now, first, I thought it might have been a fake, because notice this reed is kind of symmetric. But there's not, for every star on the right, there's not one on the left. But the labeling is not symmetric. That's the key. So while it's made to be pretty and to be symmetric, not everything is a pointer for a star. All right? Only some of them are. And it has an ecliptic, and the ecliptic is marked off correctly. And that's the North Pole, and that tells us this is a real astrolabe. So it was analysis of the reed of this instrument that allowed me to tell. I call this the Wheeler astrolabe because Andy Wheeler bought it, and he was a vice president of Bechtel Corporation. He's retired now, a little bit older than I am even. And
What latitude?
this is the reed, so this is for anywhere in the Northern Hemisphere. This works anywhere. But this instrument has 3 tympaniums. I'm going to show you them too in just a second. This is the matter. In this matter, they did not engrave a tympanium on the bottom, but they're verses from the Quran, which is not the best reproduction, so you can't all read them. But yes, they're verses from the Quran. You know, God is good, God is great. You know, that sort of thing you should expect. All right? So this is the Wheeler astrolabe. Now, here's tympanium 1. So this is latitude specific, and this is made for a specific place on the earth, and it tells you that in Farsi, because this was made near Tus, which is a ruined city outside of Mashhad. You could physically fly into Mashhad. It's a place you could visit. One of these is for Mashhad. I don't remember which one is which. And here's another one a little bit better. You can read this. Here's tympanium 2, and here's tympanium 3. This one also has something you can cast horoscopes. So remember, it walked over from Persia across to Afghanistan into India, and so a Brahmin would have used this, which would have been on his wall of his domicile, and people would have realized he was a great scholar because he has one of these. And this is how he would have been able to determine the ascendant and descendant sign of the birthday of the kid or the person, regardless of whether he had a tympanium for that particular latitude. Because this gives you, within 5 degrees, this gives you latitude of everything. So that's many astrolabes have that too. another astrolabe in a museum, Arabic astrolabe. This one's in Bologna, in an astronomical museum. Moorish, Grenada, about 1280. Astrolabes in Islam. So remember, the Greeks did these things, but it was passed to the West through Islam. So Islam has used these astrolabes to tell time, to tell you which direction to face Mecca, as well as when to say your prayers. Yes.
What's the difference between Islamic and Muslim?
Fashion. None that I'm aware of. Okay. Many
Synonyms.
people who are worshipers of Islam don't want you to say Mohammedanism because he was a person. They prefer you to say Islam. Okay, at least people like it. But anyway, Muslim astronomers, Islamic, there's really new. But here, anyway, but this is Islamic astronomy. These are a list of people. In fact, I'm going to tell you about a person, probably will not say his name right. Abdel al-Rashaman al-Sufi. And and he lived before the year 1000. And there's a Wikipedia article on it. And he wrote
That
a treatise.
his father and grandfather?
Yeah. Well, he said that his book is titled 1,000 Uses of the Astrolabe. But it doesn't have 1,000 uses of the astrolabe. It only has 386 uses of the astrolabe. Because this particular book has 386 chapters. Most chapters are only like 1 page, 2 pages maybe, right? And they determine how you can use your astrolabe to answer some astronomical question.
There is one use, you can use it for leveling things.
Yes, you can.
Stick it under one leg of a table. And
That's also true. Or you can use it to defend yourself, hit somebody over the head with it. Since many astrolabes are made out of metal, sometimes they're melted down to make weapons, cannons, pistols, swords and stuff like that. All of them. They're mainly made out of brass, so your brass swords would be the best. But now, the West got astrolabes because of Gregory Gilbert of Aurillac, who's also Sylvester II. He was a pope. He was a mathematician. He was a great scholar. He goes into Moorish Spain with his teacher, and he learns how to use the astrolabe, and he brings the astrolabe back. So the Christian West doesn't have any astrolabes until about the time this guy becomes pope, right? But later in history, you see Abelard and Heloise, they have a son. Their son's name is Astrolabe. Of course, that's a couple hundred years later in France. So by that time, astrolabes had spread to all the West. So here's my first astrolabe. Now this has an horizon that goes all the way around. So it has the complete horizon. And this doesn't show the reed. But I stuck the other part, the sun part around here, and you can see altitudes. You can see that I'm not the neatest person in the world.
I like your
My
shading.
circles aren't very good circles, So
I like your shading, it makes it easier to.
yeah, I shaded it because I like colors. But and this is made for latitude 30, which is approximate latitude of Baton Rouge. So that's the first one I ever made. And I made this based upon the instructions in the Boy Scout manual. Now I departed a little bit from the Boy Scout manual because the Boy Scout manual would have had me end before, they wouldn't have had the entire horizon. But I wanted to get it all. And the second astrolabe that I had made, by draftswoman, this has 17 stars on it, the latitude of Baton Rouge, and this shows all of it, the reed, which is a transparent piece of plastic, and the climates. And here, instead of putting the signs of zodiac, since I wasn't trying to encourage my class to cast horoscopes, I didn't put the signs of zodiac, I put the days. So you won't have to flip it over. And this is, anything here is outer darkness, anything in here is, of course, up at the moment, either daytime or nighttime. Now, this thing could also be used as a sundial. It would be a really crappy sundial near noontime. But it'd be a good sundial early in the morning and late in the evening. Because early in the morning, late in the evening, you know which side of the meridian the sun's on, right? Because the sun may not exactly rise east and set west, but it's eastward and westward, right? So, not so good in the middle of the day, because in the middle of the day, you would know which side it is. So, and one of the reasons that I did this is because Arcturus and Fomolo, is Fomolo on here? Wherever star 10 is?
Yes.
7. And these stars
Number 10.
wouldn't have rotated, wouldn't have been shown if I hadn't included so much of the horizon. And I actually had students do, these could be mass produced, right? The transparency plastic, you could produce the reed, and these things with the Xerox machine, and you could make lots of them. Now, here is when I left teaching astronomy at LSU, Fred Whittle took over. I started teaching physics labs, and Fred was out of the box thinker. So he put the reed on the bottoms. The star map is on the bottom, and the climate or the tympanium for Baton Rouge is on the top. Why not? If you're using transparency plastic, you can do that. If you're making it out of metal, you cannot. There's certain advantages to whatever material you're using. This is the Whittle astrolabe. Now this is a linear astrolabe. This is made by the Grumman Corporation. This is used as an emergency navigation device for astronauts. Okay, and this was given to me by a student. Okay, he had given to him by his uncle. He thought I'd appreciate it. He gave it to me. So what?
It's a mirror image?
Yeah, well, it's a linear astrolabe because you can see the Earth. This thing slides back and forth. This is plastic. It also has polar caps. Why does it have polar caps? Well, let's look at the back of what's on this astrolabe. It's quite grim. Stuff from the back of the Grumman linear astrolabe. Astrolabe, Astro Guide, is an emergency navigator. An astronaut in low Earth orbit may find it necessary in emergency to use navigation aids other than those provided in this capsule. For example, assuming the capsule has been successfully injected into some orbit, not necessarily for which the launch vehicle was programmed. It might even be assumed that a near polar orbit is achieved. Why would they orbit someone over the poles? Well, you're expecting an attack from the Soviets or the Chinese or something, right? So you want to monitor and from orbit.
You could watch the whole Earth.
Yeah, you can watch the whole Earth.
Or you may
We still do
watch
that.
NASA satellites for GPS.
Right, we do that for GPS too. Okay. Astronaut to determine his position above the obscuring Earth, with no aid being furnished from ground control station. Yeah, because they're all dead. Because there's been a global thermonuclear war. With his sidereal clock that he's got on his wrist and the Astro Guide, he can locate his position over the Earth at any time during the flight. So he can fire his retro rockets so he can land somewhere in some ocean or some place where he might possibly be picked up by some survivor. This is a pretty grim instrument made by the Grumman Corporation.
Compliments of the Grumman Corporation, yes.
Yes. Compliments of the Grumman Aircraft Engineering Corporation, Bethpage, you should live near there. Remember to the American Rocket Society Report Nation, October 1961. So that's when people are really worried about these things. So I'm 11 then. And now, here is a printout of a really sophisticated astrolabe. This is a computer program which runs on any Wintel machine. That'll also run DOS. And this shows all the planets along the ecliptic. So this is a really sophisticated thing. Right now, when this picture was taken, it's being used for latitude 4852, so almost 49 degrees north. You can also set this one to any time. It'll handle precession. So you could see Paul Revere's ride exactly from Boston or anywhere else, or some historical battle that occurred a long time before Jesus even. This thing would do all those calculations. This was done by Jim Morrison. He wrote this program. He also was the same person that made these. Dead now. Unfortunately, he was a smoker. He did die. I'm pretty sure it was lung cancer. But anyway, Rupert and I knew him. He was a great guy. But anyway, And this is a very sophisticated program, and it still will run on some computers. It certainly would run on Windows 3.1. I haven't yet installed it on a Windows 10 machine. I don't know whether it would really run. Who knows? He was a great programmer. He was, before he retired, he was a vice president of software sales in Europe, and that's where he ran across astrolabes in museums and fell in love with astrolabes, and did lots of interesting things with that. Now, pick up your yellow astrolabe. Okay, so this astrolabe is set for July 25th at 10 p.m. See 10 p.m.? Right, 10 p.m. And it's set for July the 10th. See July? So this is July the 10th at 10 p.m. If I had it set over here, it would be July the 10th, 9 p.m. And it's set for the latitude of Tacoma Park because that's where this particular machine is made for, right? Now, depending on which one you have, whether you have, hopefully, I have 2 or 3 different versions of these things around. Some of them have signs of zodiac, some of them have dates. This one has dates. So this is a modern version of the astrolabe. So there are some of them floating around here. And if you turn it over on the back, then you find out how to convert that to watch time, because that was assuming you set your thing right. Okay, well, what you would really do when you told time. Okay. You would then set some of these stars correctly. You would measure some stars and you would measure their altitude from the back. You would set them correctly. And then you would set the date, and that would tell you that it was 10 p.m. But it wouldn't be 10 p.m. on your watch. It would be 10 p.m. local apparent solar time from Tacoma Park or any place that has this latitude. It would also work anywhere else with that latitude. So then you would go ahead and get watch time. So watch time, or zone mean solar time, is local apparent solar time plus 1 hour or 0 hours, depending on daylight savings time. Since this is Tacoma Park, we're 8 minutes away from the time zone minus ET. Now this one has the peanut. So this is set for July the 10th, and ET at that point is what? Minus what? 8.5 minutes. So ET would be minus 8.5. So minus and minus plus, you'd have to add 8 minutes, another 8 minutes, and 1 hour, 0 hours. Then you'd have watch time. Now, a device this size is capable of getting time within 2 or 3 minutes if it's used correctly. Of course, you have to do it pretty quick, because by the time you got it all read and converted, 2 or 3 minutes have gone by. So you gotta be quick.
Are there instructions online for how to use it?
Yes, plus to some degree, when you got your astrolabe, right, it came with a book written by Morrison. So with the astrolabe came a book, Personal Astrolabe Modern Edition. So it came with a 40-page booklet and instructions. And it also came with the different climates. So you could, in case you weren't at Tacoma Park, you were someplace else, you could put one of those. And in case you wanted to cast horoscopes, you could. He didn't tell you how, but you know. And it has some of these other plates that I showed you for coordinate transformations, right, in the booklet. So Jim did it all. He also wrote a book on astrolabes. He also translated a famous book that I have with me but didn't get out, written by a Frenchman on astrolabes, on all the astrolabes. And I haven't even shown you yet an Astrolabe Quadrant. Pick up that quadrant, would you, Rudy, and hand toss it to me, that thing, yeah. This is an Astrolabe Quadrant. So generals and rich people and would have astrolabes made out of brass, maybe brass and a little bit of gold plating. But a poor astronomer, he has a string, a weight, and an astrolabe folded over 4 times. This will do everything the other thing will do, but it's a real pain to use. Okay?
Yeah.
But of course, if you're a scholar, you can suffer and you can do it.
Yeah.
So this has moving parts. The only moving parts here are the strings and the weights that you can pull through. So, and
So
this
we would
is
Google Morrison Astrolabe?
not anymore. Just Astrolabes. I did have his entire stuff up, but I didn't renew it yet, so anyway, it's off there. But there are multiple explanations now as to how to make your own astrolabe and how to print it up and so on and so forth. There's even a Java applet done by a guy named Powell in England, so you can actually run the Astrolabe program on your computer from your browser.
I was hoping to find the instructions for this one.
Well, that you'd have to get
Unlikely.
from Morrison. But I have a whole bunch of them sitting in over there.
Yeah.
So, yeah. So. And someday, I have ambition to have these things like this made again. But see, this was made, you can see, that's when Jim lived in New Fairfield, Connecticut, and you can see a date, and so on and so forth. Then he moved to Rehoboth Beach, which he considered near the Washington metro area. Of course, he thought New Fairfield was near New York City too, so he clearly liked to commute. Now, this is an Astrolabe Quadrant. And this is a link which will take you to the Canterbury Astrolabe Quadrant. And there are instructions on the internet, on here, as to, and an entire book. You can make your own Astrolabe Quadrant. So, Rudy, you can make an Astrolabe Quadrant. The instructions are off of here, and that's how I got this. And this is the last slide I think I
Canterbury
made.
Astrolabe Quadrant.
I had my daughter this morning grab this. The writer is Arabic, which is, of course, why these are Arabic, and moved over here, but he also has English and so on and so forth. And that's the end of the presentation. And you can come up and play with these things, and it's great. They're wonderful instruments. Somewhere I even have an Astrolabe Catholic for, it looks like a plain sphere on the other side, but on the other side, I think maybe this one. Yeah, no, that's not it either. That's the classical astrolabe. Classical means that it has signs of zodiac. This also is not an astrolabe. This also is not an astrolabe. These are nocturnes. These are devices for telling time at nighttime using the Big Dipper, using Cassiopeia. So it's another, not astrolabe, but sort of astrolabe-like device that rotates with the sky and can be used to give you time. So it's an interesting universe that we live in.
No, thank you for a great talk,
Okay, thank you.
and for pitching in.